believe you're enjoying this video so far. Okay, if you find this video useful, don't forget to subscribe, don't forget to like, don't forget to share with anyone out there that you think might find this video useful. Okay, so moving on, and before we move on, there's one last thing you need to know, very important thing you need to know. Okay, so let's get down to it. If you're a physical quantity in science, okay, you fall under one of these categories. Okay, all physical quantity in terms of dimensions have been categorized into 4 groups. Okay, so that is what we are going to be looking at. Please make sure you pay attention. Number 1, you're either a dimensional constant, a dimensionless constant, a dimensional variable, or a dimensionless variable. So you realize that you're either a constant or a variable. And if you're a constant, you're either dimensional or dimensionless. What does that mean? What does it mean? So let's start with the very first one, dimensional constant. So to be a dimensional constant, the first thing is that you must be a constant. Okay. So dimensional constant are simple constant values. Okay, that have units. Okay, they are constant, but they have units. Okay, so any physical quantity at all that has a fixed numerical value and has units is called a dimensional constant. Example, there are a lot of examples. Newton's gravitational constant. Okay, acceleration due to gravity. Acceleration due to gravity on the Earth's surface is fixed. Okay, it doesn't vary that much. It's constant, fairly constant, about 10 or 9.8 meters per second squared. So you see, this value is a constant, but it has dimensions because it has units. There are a lot of examples. We have Planck's constant, we have speed of light in vacuum, we have permeability, okay, of vacuum or free space, we have permittivity of free space, and so forth and so forth, so forth and so on. Okay. So now let's come to dimensionless constant. So in this case, if you are a dimensionless, in this case, if you are a dimensionless constant, okay, that means that you have to be a constant with no unit at all. Okay, it means that your value is fixed, but you have no unit at all. So example, any number at all is a dimensionless constant. Okay, trig ratios are also dimensionless constant. So you realize that E is a dimensionless constant. It's a constant number, but it has no units. If you take pi is a dimensionless constant. If you take any number at all, 1, 2, 3, 4, numerical values with no unit are dimensionless constant. Trig ratios, sine theta, cos theta are dimensionless constant. They are constant and they have no dimensions. In other words, they have no unit. Okay, so dimensional variable. Dimensional variable means that your value, okay, the value of the physical quantity varies. It's not fixed, and it also has units. So you realize that all physical quantities here derive quantity information. So by area, volume, pressure, density, they vary and they have units as well. So they will all fall under this category. So this one, there are no specific example. Okay, any physical quantity at all that varies, okay, and has units will fall under this section. Okay. Now to the very last one, dimensionless variable. That means that it is not fixed. It has no fixed value. The quantity has no fixed value, but it has dimensions. There are lots of examples. Relative density. Relative density. Coefficient of restitution. It doesn't have a dimension. They don't have symbols, okay. But then they also vary. Okay, for example, refractive index. It's another example. Another example is coefficient of friction. Okay, so with that being said, anytime you're given a physical quantity, you should be able to categorize it into one of these. Okay, you should be able to tell whether it is a dimensional constant, it's a dimensionless constant, a dimensional variable, or a dimensionless variable. whatever physical quantities, it will fit under one of these if you are looking at it in terms of 8 dimensions. Okay, and there are lots of examples of dimensionless constant and a lot other examples of dimensional constant. Okay, if you have more examples that you like to tell us, you can comment them in the section, in the comment section below, to help other viewers as well. Thank you. Now moving on, we are moving on to another very important section of dimensional analysis, that is uses of dimensional analysis. Don't forget to like, share, and leave your comment down below.